Hello, in this video I'm going to look at calculus typesettings, so integrals and derivatives. Let's have an equation, and we've got a menu full of different kinds of integrals to have here. No need to be intimidated, you'll be learning about these all in due course, and you may learn to love them or you may learn to avoid them depending on the path you take, but that's different from learning to, at least we can learn to present them properly. So we've got an indefinite integral here and a definite integral with the limits here. So if I select that and say that it's a limit integral from 0 to 1, and I can use the backwards and forwards arrows to move between these like this, then the integrand, the thing that's being integrated, goes here, and that might be x squared. And then I need a differential, a dx, to show what it's being differentiated with respect to, and I still want that to be within this highlighted box of things that belongs with the integral so that it groups together nicely, but I'm going to put a space in there just to separate it out slightly, and I can put dx like that. And a common convention, though not a universal one, if we look in this famous old textbook, you'll see that the d for the derivative there, for the differential, is upside rather than italic to indicate that it's not a variable, it's got some other meaning. And we often do the same with E when we mean Euler's constant, or I when we mean or J when we mean the imaginary unit, because they're not available to be redefined. Their values aren't up for question, and in some cases they don't even have values. So if we wanted to do that, then we would just highlight that, and we can use Control I, or I can go to the Home tab and click the I for italic there if I prefer. How would I do all that if I was just using the keyboard? Well, I can use \int, which will then autocorrect to an indefinite integral, and I could just proceed like that. But if I want to put limits on it, then I can use subscript and superscript. So I could say 0 to, and let's have the upper limit go to infinity this time, and the abbreviation for that is one you might not guess. It's INFTY, INFTY, and as long as I put the subscript and the superscript together and then autocorrect, then it goes into the limits like that. Don't just do the subscript and press space, because then it's hard to add the upper limit afterwards, and then this might be y d something else for some particularly strange set of x and y. And I'm going to right arrow to get out of that group for the next thing. Common error is to forget that you're still inside this group, then write the equal sign for the next thing. That messes up all your grouping, so always keep an eye on that. And I might also want, I'll just delete this and start again in the equation, or give myself a new equation. If I wanted one of those multiple integrals, then I could do int, or I could do a triple integral, or I could do a contour integral, one of the delights to come, and so forth. So you get the idea with that. Derivatives are usually just fractions, so we've got examples of them here. So dy by dx is often easy just to bring that in and edit it, except if you want these to be upright, then you edit them like that. If, on the other hand, you're dealing with a partial derivative, then you've got an example like that. The code for this partial derivative symbol, we'll find it if we wanted to make it on its own in the basic maths. There it is. So you would have to type \partial if you wanted one of those, which is a bit more typing, but it depends on your typing speed. But it is important to distinguish these partial derivatives, and I'm just going to change that so it's a plausible function. And sometimes you might also have, I'm going to put another equation in here. If I do a comma and then hit space twice, and then the next equation will be set a little way away from it. The one thing here, and this is a common confusion, that's delta y by delta x. That's just the Greek letter delta. That's different from partial derivatives, another set of symbols to be clear that you can write differently and distinguish both in your own writing and when you're reading documents like this. This one means the partial derivative, the rate of change with respect to that variable holding all other variables that it might depend on still. This means a small infinitesimal change, but not in the derivative limit. That's about all there is about calculus for now. When you get on to higher parts, part 2 and part 3, you might start doing vector calculus, and there's a whole set of extra symbols there, but they're easy enough to learn about when you come to them.